This Refraction and Snell's Law Lab will require pretty much just what you see here. Basic optics light source, this basic optics ray table, which I like to abbreviate BORT, a semicircular prism, which has a frosted bottom, and some tape. The first thing we need to do is turn the BORT, the ray table, over and just take a loop of tape, sticky side out, and just put that right down on that little metal thing right in the middle. And we just want to stick it to the table so that if we try and wiggle it, it's really not going to go anywhere. That allows us to rotate the top of the ray table without moving the table around on the kind of mush it down a little bit so that if it's going to go anywhere, it'll do it then rather than after we've made our setup and everything. So now we've got this, and you can see that on the ray table we have an outline, a semicircular outline, that more or less matches the prism. What we want to do is set the prism on the ray table with the frosted side down, so if you're looking and you really can't see the markings through the prism, you've got it upside down. We want this back flat edge right along that straight line labeled component as close as we can get it. Now over here, what we're trying to do is we're going to try to get the prism lined up so that the refracted ray goes directly over the normal line, just like if the prism wasn't there at all. So we want to make it back to this situation. If we're off by a lot, then you can see the angle over here is way away from zero. Now, as we adjust the prism, we don't want to knock the basic optics light source around. So the normal ray is pretty well, yes, I'm a perfectionist, right in the middle of the ray the whole way across. So we have to do two things. With the prism, we're trying to get two things at the same time. We're trying to make sure the back line is lined up with the black line labeled component on the ray table, and the refracted ray goes directly over the normal line and over the zero mark. So two things at once. Now the nice thing about it is you just shift the prism in the same direction you want the ray to move. So since it's a little bit lower on the screen than the zero line, I'm just going to shift the prism directly up a little bit. Almost there. It's over the normal line, but it's just a little bit on the edge. So I'm just going to just barely, and there I go. I've got the ray going over the normal line, the arrowhead, and the zero mark, and over here it's doing the same thing. So I'm pretty confident that this is where I want it to be. To make sure the prism doesn't move while we're making our measurements, we're just going to tape it down. And so I'm going to press straight down, don't move it. Make sure that the ray of light, the refracted ray, is still going over the zero. Make sure that the back edge is lined up. And I'm just going to push this along the edge of the prism so it's flat against the, well, not flat, but against the curve there, and then on to the surface of the ray table. And we're not trying to hold it against a hurricane force wind or anything, so it doesn't have to be perfect. We just don't want it sliding around. And you can see I jostled it a little bit. So before I tape this one down, I'm going to scooch this back to where I want it, and then I'm going to tape it down. Okay. So these are not merry-go-rounds, so don't go hog wild with the rotating. So we're ready to take measurements. The first one is set up because this is at 0 degrees, and notice that the angles are measured to the line here marked normal that's perpendicular to the prism. Same thing over here. Now, we have to make sure that neither the light source nor the prism slide around while we're doing the lab. The prism, I think, is pretty obvious, but we have to keep the light source aimed at the center of the ray table and the center of the prism. The reason for that is in order to have this measure the angle of refraction, we want the ray of light to come out of the prism. We want it to strike the surface perpendicular to the surface wherever it is that it's leaving the prism. The reason for that is because, again, we measure the angle of incidence with respect to the normal. When we have something that's a circle or part of a circle, we know that the radii are always perpendicular to the surface of the circle, or in this case the cylinder, where they intersect the surface. So as long as this is coming from the center of the prism towards the curved edge, the refracted ray will always be along a radius of the circle because it's coming out of the center, and it's always going to hit the edge at 0 degrees, and so it's not going to refract or change direction when it leaves the prism. That's the important thing about this hitting the center of this circle here on the ray table in the center of the prism. So what we do to make our measurements, we just rotate to the different angles of incidence. So the first one I believe is 5. So I rotate it until it's on that slightly longer mark that's halfway between 0 and 10. So that's 5 degrees angle of incidence. You can see it's hitting the center of the prism, and it leaves the prism. We can read the angle of refraction over here. And so if you looked real carefully, it would be 1, 2, 3. The ray of light is between the 3 and the 4 degree marks. So the way I would write that down on my paper, since it's between 3 and 4 degrees, I would write that as 3.5. So we want to write down at least a 0.0 or a 0.5 when we write down our measurements. So I'm going to turn this, so 10 degrees, read the angle, write it down. 20 degrees I think is on the list, yep. Read the angle of refraction, write it down. Read, see, 30 degrees, straight along the 30 degree line. Read the angle of refraction, write it down, and so on. Once you get out to here, it's going to go by twos. So 76, not this, there we go, 76, 78, I think. Nope, that's 79, 78 right there. You can see the refracted beam over here. 80, and I think 82. You can still kind of see, and that's pretty much what you do. Before you pack up, look at this, think about it, fix it in your memory, because one of the things I want you to do for this lab is to draw, and you can look at the written directions to see the kind of thing I'm looking for when I talk about a sketch. You could use a compass or draw around something circular if you wanted to. It's not necessary. You can also take a picture with your phone, plug your phone into either the printer, I'm not sure that'll work, or one of the laptops. Dump the image to the laptop and print it out. You can just use the Microsoft Photo Viewer. We don't need anything fancy. Just keep in mind that if you do print out your photograph, you want it small enough that you can cut it out and tape it into your lab notebook and have it look good. And that's pretty much it.